So the syllabus says you only need to go from the monomers to the link, but I don't know if it's called complex unfamiliar to go the opposite way, so we're just going to look at everything. So what are condensation reactions? They are small molecules coming off when two functional groups join up. And so the ones we're going to focus on are just the carboxylic acid and alcohol. So the OH comes off each time from the carboxylic acid side, and the carboxylic acid plus the amine to make the amine links, so polyesters and polyamines. To get ammonia, it's usually ionic compounds or ammonium compounds, which we're not going to have. And you could have halogen alkane and an amine. That could give off a HCl. So just be aware of that. So just be aware of two functional groups coming together could release something else, and that's still a condensation reaction. Okay, so to start off with, we're not doing the polymers, we're just doing how to make an ester, and you just grab a carboxylic acid and alcohol and remove the water, and there you go, there's your ester, and you can reverse it. So you need to know that reaction. The polymers are just the two, as I said before: alcohol, carboxylic acid, amine, carboxylic acid, and then it wants you to talk about biomolecules. So that'll be perhaps a different combo in there, so I'll get to that soon. So polyesters, creating the ester link, just recognize the OH from the carboxylic acid and a H from an alcohol and remove them and join them, and then just do that repetitively. So just a few more examples. You can see there's carboxylic acid, there's an alcohol, get rid of them, join it up right here, and just keep adding them together. Common one, PET. So that's terephthalate. So terephthalate plus has got the carboxylic acid, and that should just be this bit coming off. Ethane 1,2-diol, and there you go. Just be aware that you just be able to recognize where the carboxylic acid and alcohol form. So just grab a H and an OH, and you go, because that's water, and just put it back in there so that you can go in the reverse direction if you need to. All right, polyamides, carboxylic acid and amine this time. So the H has to come from the amine because there's no choice this time. There's the OH from the carboxylic acid. Recognize the amine link. Be able to put the OH and the H back in there and break it up and go back to the monomers. Okay, so this is nylon, if you're curious, different types of nylons, but you can see that the functional groups and how they join up each time. Oh, and don't forget to say there's water coming off or going in, depending on which direction you've been asked to do. Kevlar is a common one too, if you're curious. That just has nicely lined up hydrogen bonds between them, so that's why it's super strong. And the biomolecules finally. Okay, so condensation is making, so that is anabolic, and catabolic is breaking down. So you put the water back in and get back to the monomers. All right, so we'll just go through the three main biomolecules: carbohydrates, proteins, and lipids. So proteins is still an amide, but we call it a peptide bond, so nothing different there. Moving on. Carbohydrates is different. This is just two alcohols now, so that's not meant to work, but it will because we have enzymes and the cell can do it. So anything's possible with enzymes. Okay, so that one is a tough one because, how do you know it's not breaking there or something? Okay. This one here is the lipids now. So that's carboxylic acid and alcohol again, removing the waters to get to fatty acids and glycerol and vice versa. Okay, so just a problem here. Now this is admittedly a nasty one. I did say it's a polypeptide and draw the monomers. I could have said two. So you've got to try and find out where the amide link is and then break it up, and that's what the two monomers are. And so this is how I would go about it. I'd actually redraw the whole thing out. The only amide link is here. If you can see the C double bond N, that's the only amide link. There's no C double bond N. That's just a functional group on the end. That's not joined to an amino acid. So that's the only one. So that's where you split it. So the OH goes there and the H goes there, and you can redraw it like this. Okay, this one's here is an actual error. Should be a H, O, not a OH. And that's the monomers redrawn out. All right, so this could react with this or this could react with this, and it matters which one's which because that's a different polypeptide, and I don't know which one that is, but you can look at that in more detail if you wish. That will certainly make a big difference if it's a longer protein because everything must be in the correct order in the correct direction. Okay, so that's a tough question. Yeah, okay. Maybe try some easy ones going back and forth between the two, monomers to polymers, polymers to monomers.